Welcome to this session on business mathematics. Our today's topic is anti-logarithms. This is a brief outline of this module. In the previous modules, we have covered topics like introduction to logarithms, properties of logarithms, rules and laws of logarithms, how to find logarithm of a number, and today in this module, we would be covering how to find anti-logarithm of a number. Let us now begin. Let us now define what is anti-logarithm. Anti-logarithm of any number is that number whose logarithm is the given value or given number. Let us understand this. If we have x is equal to log of n to the base a, this n is called anti-logarithm of a. That means this n value is actually anti-logarithm or opposite of logarithm. Here, if it is denoted as n is equal to anti-logarithm of x, or we can write it as n is equal to ALX. You can use any of these notations at one time. In order to find anti-logarithm, we make use of AntiLog Table. Here, one important thing to note is that the input value of finding AntiLog Table is not a normal number, it is actually a log value. Whereas if you compare it with the logarithm value, the input value supplied to the logarithm value is actually a normal number. But here, anti-log value have the input value as a log value. The log value is comprised of two parts. First part is characteristic and the second part is mantissa. Now for indexing into the anti-log table, what we do, we ignore the characteristic value, we only use mantissa. What we do, we only use the mantissa part for indexing into the anti-log table, we ignore the characteristic value at first glance. The point of decimal in the number obtained from the anti-log table is adjusted with the help of the characteristic value of the given number at last. That means after we have found the value of using the mantissa from the anti-log table, we put decimal signs on the basis of the given characteristic value at the last. Let us now understand what is an anti-log table. Here, this is a snapshot of an anti-log table. This anti-log table contains values from 0 to 9 on the extreme left-hand side corner. This is called the main part. And like the log table, we have the mean difference part. Here, the mean difference part has the values from 1 to 9. That means, but the difference here is that in log values, the values start from 1, 0. But here, the values start from 0.00. It will go up till 0.99. Alright? Now, this value from 0 to 9, that is from here 0 to this 9, this is called the main part, and the next value that is from 1 to 9, this is called the mean difference part. So this whole contains the values which gives the index of the row. This whole will give you the main part value, and here there is also a side table. As I already mentioned, this is a mean difference part, and this contains values from 1 to 9, just like in log table we have. Then what we do, we just add all the values that are obtained from the main part as well as from the mean difference part to get the final value. Now let us understand some rules to find anti-log from a table. In case of a negative logarithm, the mantissa must be first converted into a positive mantissa, otherwise we cannot make any entry into the log table. Why? Because our mantissa should always be positive, as the values in the anti-log table starts with 0.00, which is a positive value. So we have to convert a negative mantissa into a positive mantissa. Then, like in the log table, we have the first two digits will give you the row position, the next value would give you the column position in the main part, and the next last fourth value will give the column position in the mean difference part. So what we do, we proceed along the row until the column value in the main part, that is the third digit, is reached. We note down the corresponding value at that row and column position. Then we again proceed towards the row at the end of the fourth column, where we get the fourth digit value, which is a mean difference part. Here we again read off the value and add up the two values. This will give us the desired number. That means the value on the basis of which we will calculate the anti-log value. This is called a desired number. Now, what we do, after we have found out the desired value, we use the characteristic value of the given log value to put decimals into this desired value, and that value is known as the final value. Okay? So, now there are two cases. The first case is either our characteristic is positive, that means more than 0, or our characteristic will be a negative value, which is less than 0. If our characteristic value is greater than 0, that is positive value, then the number of digits in the integer part will be 1 more than the characteristic value. Now in case number 2, if our characteristic is negative, that is less than 0, then the number of zeros immediately after the decimal would be 1 less than the characteristic value. This is just opposite to what we have in logarithm, right? So I again repeat, we have two cases. First, our characteristic is positive value, and the second case, our characteristic is negative value. If it is a positive value, then the number of digits in the integer part would be 1 more than the characteristic value, and if it is less than 0, that is the negative value, the number of zeros immediately after decimal would be 1 less than the characteristic value. Now let us understand this with an example. Here we need to find anti-log of 2.5321. Here what we do, first we look at this number. This is actually a log value. That means it is composed of characteristic as well as the mantissa value. Here we have the characteristic value as 2, which is the integer part, and mantissa value is 0.5321, which is the decimal part. Now to index into the anti-log table as mentioned earlier, we will use this mantissa. Since it is already a 4-digit value, so we will take the mantissa as 0.5321. Here, including the decimal, we will use the first 2 digits to index into the row. The next value is for the column in the main part, and the next value is for the column in the mean difference part. So, the figure corresponding to the row number 0.53, column number 2 in the main body using the anti-log table would be 3404. We note down this value. The second, we continue in this same row 0.53, we move to the column 1, which is the 4th value, and the mean difference value is 1. What we will do, we will add up these two values together. That means adding both the values, we have 3404 plus 1, the answer is 3405. This is our desired value. It is not the final value because we have to use the characteristic value to put decimal into this value. So using the characteristic to put decimal value, we have here the characteristic is 2. That means this value is positive value. So here if the characteristic value is positive, the decimal placed at the position 1 more than the characteristic value. That means we have to put decimal after 3 places. So we have final value as 340.5. I have to place decimal after 3 places. This is how we put decimals using the characteristic value on the value obtained from the anti-log table. Hence, the anti-log value of 2.5321 is equal to 340.5. Let's move on to the next value. Here we need to find anti-log of minus of 2.7438. Here this minus 2 is a characteristic value and 0.7438 is a mantissa value. We can also write this negative characteristic as 2 bar and we will use the mantissa as 0.7438. It is again a 4-digit value, so we need not to reduce this. That means indexing into the anti-log table using the value 0.7438. The first 2 value, that is 0.74, will give you the corresponding row. The next value 3 will give you the corresponding column. The value here in the main body part would be 5534. Continuing in the same row in the anti-log table, we have the column value 8. That means the mean difference value at that particular position would be 10. Now we have to add these two values. Therefore, we get 5534 plus 10, which gives out as 5544. Now this is called a desired value. This is a desired value for us. Now we will use the supplied characteristic value to put decimal here. Since we have a negative characteristic, that means we have to add zeros immediately after decimal. How do we get that value? Here, using the characteristic to put decimal point in desired value, we have the characteristic value is 2 bar, that is a negative value. So we have to place zeros immediately after decimal. How many zeros? It is 1 less than the desired characteristic value. Here the characteristic value is 2 bar, we will take 2 value here. So it's 2 minus 1, that is 1. That means we have to add 1 zero after decimal to make it into a final answer. That means our value is 0.05544. We have to add 1 zero after decimal here. Clear? So this is the value. Hence, anti-log of 2 bar 0.7438 is equal to 0.5544. I hope these things are clear to you. Let us take another example. We have the value anti-log of minus of 0.1694. Now here if you notice, we don't have any integer value because we can write 0.1694 as 0.1694. That means the integer part negative, decimal part non-negative. But here we don't have any integer part. That means this whole part, which is a decimal part, is negative. This indicates that our mantissa is negative. But if you recall, our mantissa in log or anti-log cannot be a negative value. So in such cases, we have to convert this negative mantissa into positive mantissa first before solving the problem. So the given value is negative. That means our mantissa is negative, which is not allowed. So what we will do, we will make this negative mantissa a positive mantissa by adding and subtracting 1. So I can write this as minus of 1.694 plus 1 minus 1. On rearranging this, I can write it as minus of 1 plus 1 minus 0.1694. Here, this is a mantissa part and this is a characteristic part. If you recall, any log value can have a negative characteristic, but mantissa has to be positive. That's why we are doing this plus 1 and minus 1. Now, if I subtract 0.1694 from 1, it is now converted into a positive value, which is 0.8306. Our characteristic is negative, which I can write it as 1 bar 0.8306. So in this way, this negative mantissa is converted into a positive mantissa here. Now we can use it to find the anti-log value. Here, this 0.8306 will be used to index into the anti-log table, and this is again a 4-digit value. So we will use 0.8306 to index into the anti-log table. Here, corresponding to row number 0.83, column number 0, in the main body we have the value as 6761 from the anti-log table. Next, continuing in the same row, we have row number 0.83, column number 1, the mean difference value is 9. We have to add these two values. It gives out 6770. This is called a desired number or desired value. Now we will use the characteristic value to put decimal into it. Here the characteristic value is 1 bar. That means number of zeros to be put immediately after decimal would be 1 less than this characteristic value. 1 minus 1 will give out 0. That means we need not to add any 0 after the decimal. So our final value would be 0.6770. This is the final value. Hence, anti-log of minus 0.1694 is equal to 0.6770. This is how we find anti-logarithm of any value. Let us now look back and see what we have covered in this module. In this module, we have covered the concept of anti-logarithm. We have seen how to use anti-logarithm table. We have seen rules of finding anti-logarithms, and we have seen some numerical problems on anti-logarithm. In the next module, we will be covering how we use logarithm and anti-logarithm together to solve problems. Until then, keep learning. Thank you.